Well, hello guys, here Mr. G with another video for the grade 12. This is going to be question 7 from the Eastern Cape question paper done in 2023 in September. However, this question is related to electrostatic and therefore is also applicable for the grade 11. So before we carry on, subscribe for the channel and like the video so you can get the notification of the videos I post on regular basis. This question says 2-point charges P and T are placed 0,03 meters apart. The charge on P is 36 times 10 to the minus 6 coulombs, while T carries a charge of 16 times 10 to the minus 6 coulombs of unknown sign. So we don't know what is the sign of this specific charge here. We don't know that. Okay, now state Coulomb's law in words. And we're going to write that definitions right here at the bottom there. So Coulomb's law states that the electrostatic force exerted by 1-point charge on another is directly proportional to the product of the charges. And guys, that one will carry the first mark. The force is, the electrostatic force is directly proportional to the product of the charges. If you say that, you'll get 1 mark. And is inversely proportional to the square of the distance between them. That one is the second mark for the definition. Let's go to question 7.2. They say draw the electrostatic field pattern around a positive charge. Okay, so you have a positive charge and then you are going to draw the electric field pattern. And this one is question 7.2. So the first thing we are going to do is to draw the positive charge. And then we are going to draw the electric field pattern. Well, if you have an isolated charge like this one, either positive or negative, and you are going to draw an electric field pattern, all the lines are going to be radial out of the charge in this specific way, straight. They cannot turn. So that is how you draw it, either for positive or negative. The difference is if the charge is positive, as we have here a positive charge, then the direction is going to be out of the charge. That is the only difference between the positive and the negative. If the charge is negative, everything is the same, but instead of the arrow be pointing away from the charge, it will be pointing towards the charge. And this one, guys, is the question 7.2. Let's go to question 7.3. We can answer here. I think it's enough space. Question 7.3, calculate the magnitude of the force that charge P and T exert on each other. And they want only the magnitude of the force. Now, to do this one, we're going to use Coulomb's law, the formula of Coulomb's law. And if you go to the formulas to electrostatic, here is Coulomb's law, the formula. Guys, not mistake. And the other thing is K, which is a constant. You can look for it in the table of constants, which is a little bit top. There is the value of K. Please don't make mistake when you substituting K or when you're writing the formula there. So we come here, we are going to write the formula. It's F is equal to K, Q1, Q2, divided by the distance square. It doesn't matter if you use capital Q or small q. We are going to substitute everything we have. Remember K, you look for it in the formula table of constants. 10 to the 9, and then the magnitude of the charges. Now, something important. When you're writing these numbers here, you are not going to substitute the signs of the charge. It will be incorrect if you do that. This 2 times 10 to the 10 to the minus 6. This is the magnitude. And the next one is 16 times 10 to the minus 6. So you don't substitute the positive and the negative by the substitution of the charge. The distance is 0,03 square, and remember this one must be in meters. So if it's given to you in millimeters or something like that, you will have to convert. Guys, the rest is calculation. When you do the calculation, you will get the answer is 5,760 Newton. No direction needed because they only want the magnitude. And this one is the answer. Now, important, this question will have 3 marks. 1 mark they gave for the formula, which you all can get that mark, 1 for the whole substitution and 1 for the final answer. So if we go here, we have already 2 marks there. We have 3 marks for this drawing here, which everyone can get. And the mark is for the direction, for all the lines coming out in straight line, and all of them are touching the sphere and not crossing each other. There will be 3 marks there. Guys, this is the first part of the question. Out of 16 marks, you already have 2 plus 6 is 8 marks. So you can get all those 8 marks quite simple, and that is 50% of the question. The rest of the question said the following. When a test charge is placed, now remember something here about the test charge. Test charge are always going to be positive. Always test charge always are positive. So this point here is not a charge, it's a test charge, so it's going to be for sure positive. Always they are positive. Place at point X a distance Rm from the right to the charge T, as shown in the diagram below. The test charge remains stationary, it doesn't move. Okay, write down the sign of the charge, positive or negative, of T. Explain your answer. Okay, let's quickly have a small analysis there. Remember that one there is positive. Okay, positive. So it is going to experience a positive a force from charge P to the right, because you know this is positive, and like charges positive and positive will push each other. So there is going to be a force acting on that point charge to the right, which let me fix that arrow there, which is going to be the force from, this force is going to be from P on, let's fix this one, P on X, let's call it like that, and it's to the right. Why is to the right? Is positive and positive. Now they say that X is not moving, it's stationary, and they highlighted, or let's say rather they wrote it in capital letters, that the charge is stationary. So if T was positive, if it was positive, will be also pushing away this charge to the right, and eventually the charge will have to move to the right. So for the charge not to move, there must be a force pulling it to the left, and that is going to be due to T. So for this charge not to move, there must be a force of equal magnitude to the force P on X, and this force must be the force from T on X, which is to the left. And if this charge is positive, the force of T to be to the left means that this one must be a negative charge. It's quite simple. I hope you understand this explanation. Okay, so what we have to answer in this question, first of all, we have to select it is a negative charge, so T is negative. All right, now how are we going to explain this one? Now remember, we're speaking about electric field in this case, so the electric field, net electric field at X is equal to 0. That is why it's not moving. The net electric field is equal to 0. For the net electric field to be 0, it must be that the net electric field, or the electric field of P, must be equal to the electric field of Q. Okay, they must be equal, otherwise it won't be happening, but in the opposite direction. I'm going to write here in opposite direction. So that is things you have to say, which I draw it here, and I spoke about forces, but remember we're speaking now about electric field. Okay, so if the electric field on P is to the right, it means that the electric field on T, or from T, must be to the left. Now remember, once more, I use the forces to explain, but we are in actual fact speaking about electric field. So they say calculate the distance R. Let's leave that on there. It's quite simple. I don't want to get too much, and the drawing is all the explanation. Calculate the distance R, and this one could be now a little bit tricky. So let's go to a new page to answer this question. All right, and here we are with the redrawing. So let's see this one. They want us to calculate this distance here. Okay, let's redraw quickly the electric field. Now we are going to speak about the electric field. Due to P, the electric field is pointing to the right, because remember the test charge is always positive. I'm going to call this one EP. And then due to charge T, it's going to be to the left, same magnitude. Okay, so this one here will be ET. There we go. So now let's see how we calculate that distance there. The first thing we're going to say is that the E net, let's use maybe another color. We're going to say that E net on X is equal to 0. The object is not moving, the E net there is equal to 0. Okay, now we must select the direction. Let's say right, and let me write it here. right is going to be a positive. So all vectors pointing to the right will be positive, and any vector pointing to the left will be negative. So if we come back here, net electric field at X will be the vector addition of P and T. Okay, so but now P is positive, so is P EP minus ET, and this one is equal to 0. All right, now if we rearrange this one, we'll get that EP is equal to ET. That one is rearranged. If you want, you can start from here, but be careful with the sign. If you write one of them negative, you'll get a wrong answer. The negative was substitute at this specific point there. Okay, that's why I'm doing it in this way. Now, how to calculate the electric field at any point? If you go to the formulas, here is the formula that we are going to use to calculate the electric field at any point there. So let's substitute it for P and for T. Here will be K multiplied by the charge P divided by the distance. I'm going to call distance P square equal to K multiplied by the charge T divided by the distance T square. I write distance P and distance T because now we go to the picture here. You need to notice that the distance from P is from here to there. Okay, so in other words, this distance here is going to be not other thing than 0,03 plus X. Okay, and that is very important here. So we are going to come down here and substitute that one there. Okay, so we're going to have that is K QP divided by the distance. The distance is 0,03 plus X, and all that is going to be square. This is equal to K QT and distance T. This one is a T here square. Which one is distance T? Well, distance T is only X. This is distance T, that distance there, and is X. So it will be substituted here by X, by X square. Okay, I hope you understand this one here. And then guys, just substituting. If you notice here, the K's can simplify each other, so you actually don't have to substitute in the question here. So we can now substitute the charges here. So what we have, this one is 36 times 10 to the minus 6 divided by 0,03 plus, it's not a times, it's a plus here, plus X, and everything is square. Let's move it a little bit up. There we go. All this is equal to charge on T 16. We do not substitute the signs here. Please be careful with that one there. Times 10 to the minus 6 divided by X squared. So now we're going to take and rearrange this. We're going to do cross product actually here. So we're going to do the following here. We are going to move the 36, we're going to keep it there. 36 times 10 to the minus 6 divided by 16 times 10 to the minus 6, and the other side will have 0,03 plus X squared divided by X squared. We are here. Okay, now we can also cancel the 10 times to the minus 6. This is simple math, so we can cancel this one and this one there. So what do we have here? What do we have here? And we're going to take all this one. I don't want to go to a new page. Let's take all this one and move it a little bit to the left there, so we can work up here. So what do we have? We have 36 divided by 16 is equal to 0,03 plus X, everything squared, divided by X squared. So we have here, if we solve this one, we have that this is 9/4, and this is equal to 0,03 plus X, everything squared, divided by X squared. Now we can get the square root of both sides there. Okay, now if we do that, the squares will cancel, and then we get that this is 3/2 equal to 0,03 plus x. Remember, the squares will cancel with the square root as well as that square there. So divided by x. And this is cross product once more. When we solve this one, I think it's enough space here. We have 3x is equal to 2 that multiplies 0,03 plus x. Okay, let's go to a new page there. So this one will be 3x is equal to 0,06 plus 2x. When you rearrange this one, you will get that is 3x minus 2x is equal to 0,06. Guys, x will be equal to 0,06 meters. This is the answer of this specific question. It's a very good question to practice. It's a little bit tricky, but please, I hope you understand. If you don't understand, you're free to send me any message and I will answer immediately. Thank you for watching. This is all about this question. If you didn't subscribe yet, then subscribe for the channel, like the video. I'll see you next time. Next time we're going to be answering a question on electric circuit. Don't miss that video. But thank you. I'll see you next time. Mr. G here.